Welcome. In this session, we'll continue our discussion of finding critical values. We'll do two more examples which take a little bit more work than the simple examples we did last time. Our first example is x minus 2 power 4 times x minus 4 quantity squared. It's fairly typical of problems where we have two factors. So you start by doing the product rule, but then you have to be careful about how you simplify it. The differentiation here is a little bit more involved, so let's go through that in somewhat more detail. Since I have a product, I will use the product rule. The first factor is x minus 2 power 4. It's power of an expression, so I have to use the power rule and chain rule. First differentiate for the exponent 4, which gives me 4 times x minus 2 to the power 3 times the derivative of what is inside the parenthesis. That is to say, derivative of x minus 2, that's 1. So it really doesn't make that much difference. Times second factor x minus 4 quantity squared plus x minus 2 power 4 times derivative of x minus 4 to the power 2. So first differentiate for the exponent 2. This gives me 2 times x minus 4 times the derivative of x minus 4, which is just 1 again. Now we need to find where this is 0, and since I have a polynomial, the only general technique I know is factorization, so I'm going to try and factor this. I have two terms. Let's look for factors common to both terms. In the coefficient slot, I have 4 in the first part, 2 in the second. 2 is a factor common to both, so I can pull that out. In the first part, I have x minus 2 power 3. Second, I have x minus 2 power 4. X minus 2 to the power 3 is common to both. It's a factor of both of them. Finally, I have x minus 4 power 2 and x minus 4. So I can also factor out x minus 4. So altogether, I can factor out a 2, x minus 2 to the power 3 and x minus 4. So let's factor that out. What will be left inside? In the first portion, I had a 4, I factored out a 2, that leaves a 2 inside. I have x minus 2 to the power 3, I'm factoring that out. And have x minus 4 power 2, I'm factoring out x minus 4, that leaves an x minus 4 inside. So altogether I have 2 times x minus 4 from the first term here. In the second, I have a 2 which I factor out. I have x minus 4, I factor that out. Have x minus 2 power 4, I'm factoring out only x minus 2 power 3, that leaves another factor of x minus 2 inside. Let's simplify the expression inside the braces. I distribute the 2 and then combine like terms. So the final factorization is 2 times x minus 2 power 3 times x minus 4 times 3x minus 10. This is always defined, so f is always differentiable. Since I have the complete factorization, I can read off the zeros of f prime. The first factor is x minus 2 power 3, it's 0 when x is 2. Second factor is x minus 4, it's 0 when x is 4. The third factor is 3x minus 10, it's 0 when 3x is 10 or x is 10 third. So these are our critical values for this function. We will do one final example, this time involving an exponential. We'll find the critical values of x squared times e power negative x. This is somewhat similar to a problem we did a while back. We found the points on the graph of x squared e power x where the tangent is horizontal. This is essentially finding the critical points of the function x squared e power x. We are going to get something similar in the example we are doing now. The difference is that I have e power negative x. It makes a slight difference in the derivative. Again, since I have a product, I'm going to use the product rule. The first factor is x squared, its derivative is 2x times the second factor e power negative x plus x squared times the derivative of e power negative x. I have an exponential function, so I get with base e, so I get the exponential times derivative of the exponent. The exponent is negative x, its derivative is negative 1. Note that this is always defined, but we need to find where it is 0, so I need to factor. If I look at the two terms, I have x as a factor, and also I have e power negative x as a factor, so I can pull out both of those. In the first term, I have 2x times e power negative x. I'm factoring out x e power negative x. That leaves just the 2 inside. In the second term, I have x squared. I factored out an x. That leaves an x. We factor out e to the negative x, but then there is a negative 1. So I get x times negative 1 or negative x. So strictly speaking, I have 3 factors. So x is 0 means that f prime will be 0. But e power negative x can never be 0. So the second possibility doesn't happen. Or the third factor 2 minus x can be 0, which means x must be 2. So I get only 2 critical values, 0 and 2. This concludes our look at the techniques for finding critical values. And I will stop here. Goodbye for now.